mean, yeah, it is now, but...
We are up next, you guys, in our work that we're going to be working with where we were factoring is we're going to be using our factored answers to graph those ax squared plus bx plus c equations. And before we do that, I want to just refresh things that you look for when you graph. And so we started graphing lines. We have two different forms, y equals mx plus b form, that slope intercept, where m is the slope and b is the y-intercept. And if I know those two things, then I can graph my my line pretty nicely. So in this equation, my slope is 8/5, not x. A lot of times people want to put the x after. And my y-intercept is -5. That's a point, 0, -5. It plots as a point. So I go to 0, -5, I make a point, and then I take my slope from there up 1, 2, 3, 4, 5, 6, 7, 8 over 5. 1, 2, 3, make my other point, and the best of my ability, connect my points to make my line. So my slope of my y-intercept will give me my line pretty nicely. We did have special cases here, like in 2 and 3, where I'm missing some information. In number 3, because it's y equals, it gives me my y-intercept at 0, -5. Because there is no x term, that makes my slope 0. So if I plot my point at -5, a slope of 0 is a flat line. That means there is no rise. And so I just draw this flat line that crosses the y-axis at -5. But all of the ones that we're doing today are linear equations. The other sort of special instance or special case that we got was when we had x equals. And because when I have x equals, I don't have a y-intercept, I have an x-intercept. X equals -1. That's a point -1, 0. This is the only case that's like that, where I don't have a y-intercept. I only have an x-intercept. That means it crosses the x-axis at -1. That means my slope is undefined because I don't even have a y. And so when I graph that, it's just this straight up and down line that crosses the x-axis. Again, these are two sort of special cases, y equals and x equals. Y equals is a slope of 0, x equals is a slope that's undefined. But everything else, when it's in y equals mx plus b form, even if I don't have a b part of it, I can assume that end part is 0. And so when I am graphing this, I have a slope of -4/5 and a y-intercept of 0, 0. So I put my little point at 0, 0. Remember, negative slopes include one negative move. Up and right are positive. Down and left are negative. If I have one negative, or if my slope is negative, I'm one negative move only. So it's either down 4, right 5, or up 4, left 5. You can tell you do it right because a negative slope should create a line that drops as opposed to a positive slope that rises. When you do a positive slope, you can go up and right or down and left. This is the form that I think most of you guys are most familiar with. We've worked with this one the absolute most, y equals mx plus b. But we did do a couple that were this year already, that were in what I call standard form. And so those are the last two that we're going to review. Get the little notes down so that you can refer to it when you work on your homework. But when I have problems like this in standard form is ax plus by equals c. And my slope uses two of the letters. It's the opposite of whatever a is over b. Do you guys kind of remember doing that a little bit? And my y-intercept uses two of the letters as well. My y-intercept is c over b. And so when I write the y-intercept, it'll be the point 0, comma, c over b. So if I look at problem number 5, 7 is A, 3 is B, 6 is C. So if I write my slope, I do the opposite of A over B. And my y-intercept, which is 0, comma, c over b, I'll do 6 over 3. Or I can write that as 0, 2. In fact, that's the easier way to look at it. So I plot my point at 2 on the y-axis, and then I take my slope from there. Like I said before, if you have a negative slope, you need to do one negative move. You could go down and right or up and left, but sometimes on your graph you don't have enough room to go one way or the other. And so in here, if I'm going down 7 over 3, I'll be able to stay on the graph, but if I chose to go up 7, left 3, I would be off the graph. So sometimes you're going to have to kind of plan ahead. So down 7, right 3, connect my points, and make my line. These guys here are the ones that it's kind of hard to remember what those are. That's why having them in your notes is really helpful to look back. And you may want to kind of jot that down in a place where you can see it. Again, it goes ax plus by equals c. And your slope is the opposite of a over b. And your y-intercept is the c over b. But we plot it as the point 0, comma, c over b. So those little formulas you have to think about. When we do our last one, I have 5 is A is 5, B is negative 4, because it's minus 4, and C is 12. So when I find my slope is the opposite of A, means if it's positive, I make it negative. If it's negative, I make it positive. Over B, 2 negatives make a positive, so that's 5/4. But remember, I could go up and right, or I could go down and left, whatever fits on my graph when I make it. And my y-intercept is C over B, 12 over negative 4, or negative 3, which I plot as 0, negative 3. C over B, 12 over negative 4. So again, I'll start at negative 3, and I'll use my slope, up 5, right 4, make a point, and connect my lines. So again, up next is graphing quadrilaterals. Those are the ax squared plus bx plus c. And we look for important things. In lines, we look for slope and our y-intercept. In quadrilaterals, we're going to look for some other important pieces that are going to help us graph it. And we'll start working on that in 2 days.